Welcome to Algebra 1 Honors. We are going to look at Lesson 11-10, Solving Radical Equations. Now, the whole key to solving radical equations is to isolate the term with the radical in it. So, i.e. to get the radical all by itself. Now, in this equation, this one, and this one, the radical is already all by itself on one side. Doesn't matter which side, but it has to be just a radical sign. It can be a cube root or a square root or whatever, but it has to be just the radical sign. Everything has to be underneath that radical sign. And then all the other numbers or terms have to be on the other side of the equation. So here we don't have the radical isolated yet, because there's a 2 on the outside, there's a 4 added here. Up here there's a 4 added. We don't have the radical all by itself on one side. So the key to solving these kind of equations is to isolate or get the radical all by itself. Once you get it all by itself, if it's a square root, to get rid of the radical sign, you're going to square both sides. So undoing square rooting, you do by squaring. Just like you undo addition by subtracting, okay, you undo square rooting by squaring, the opposite operation. Okay, so we have this one here, square root of a number is equal to 5. Well, what we're going to do to get rid of the radical, since it's a square here, we don't write the 2, but it's a square root, we square both sides. When we square this side, we get n, and when we square 5, we get 5 times 5, or 25. And that's our answer. You put 25 under there. The square root of 25 is 5. Now, just as kind of an aside, 25 has another square root. Okay, a negative number, but if we wanted the negative square root, just by convention, just by definition, if we wanted the negative square root, we would write negative square root of n, okay, equals negative 5. And then if we put 25 under here, we'd get negative 5, okay? So, if you ever see something like square root of n equals negative 5, without the minus out here, there's no answer to this. Now, when you get into Algebra 2, you'll go into imaginary numbers, okay? And then there will be an answer. But for right now, the square root of a number with no minus out here has got to be a positive number or 0. Okay, square root of 0 is 0. All right, now let's move on to this one. So we have the radical isolated, it's there by itself. We need to square both sides. When I square a square root, it gets rid of the radical sign. So I'm left with 3a, okay? And I square 9 and I get 81. 9 times 9 is 81. Now to find a, I have to divide both sides by 3. And a is equal to 27. Okay? Now, this one looks kind of hard, but actually it's not. The radical is isolated. Radical's over here by itself. Square both sides. Squaring simply gets rid of the square root. Doesn't change what's underneath. So now we have m plus 5. Square 1. 1 times 1 is 1. Now, that's simple enough. We take 5 away from each side, and we get m is negative 4. Now let's check it. If we go back, which is something we should do, if we go back and we put negative 4 in for m right here, we get negative 4 plus 5 is 1, positive 1, and the square root of positive 1 is positive 1. All right, let's look at this one. Now, this one does not have the radical isolated. So first thing we have to do is to isolate it. We need to subtract 4 from both sides. And then we'll have just the square root of 2x over here equal to 6. Okay. Now the radical is all by itself there. We square both sides, we get 2x equals 36. To find x, we divide both sides by 2, and x is 18. Okay, now let's look at 2 that I wouldn't say are hard, but they're a little more interesting. Let's try this one here first. All right? So let me rewrite it up at the top here. We've got the square root of a squared plus 3a equals 2. Now, the radical is isolated. The radical's over there all by itself. It's kind of complicated underneath it, but the radical's here just by itself. So now we're going to get rid of the square root by squaring both sides. Square here, and I get a squared plus 3a. Square this side, 2 times 2, I get 4. Oh, now this ought to be ringing all kind of bells in your factoring part of your brain. Because to solve here, what we need to do is collect all of our terms on one side, so we subtract the 4 from each side, and then we're going to factor. Okay, we're going to factor. We need a number whose, two numbers whose product is going to be -4. So when we multiply them, we want -4. And when we add those two numbers, we want a +3. Okay, so one of the numbers is going to be negative and one's going to be positive. What if we had a +4 times a -1? Let's see, that gives us our -4 when we multiply. And when we add +4 and -1, we get +3. So those are our two numbers. So this is going to factor into a minus 1 times a plus 4 equals 0. Now, I'm going to have two answers because I have two things multiplied together here. This one can be 0, and my answer will be 0, or this one can be 0. So what makes a minus 1 equal to 0? Well, if I put in a 1 for a, 1 minus 1 would give me a 0 here. And that wouldn't matter what's here. I'd still get 0. What makes this one 0? Well, if I put in a -4 for a, because -4 plus 4 gives me a 0 here, and then 0 times anything here gives me a 0. So I have two answers, 1 and -4. And I should always check them because sometimes in square roots, when working with radicals, through nothing we do wrong, sometimes some of our answers just don't work. Okay, and it has to do with that positive and negative thing. So if we take a +1 and we plug it in, let's see. We get 1 squared, which is 1. 1 plus 3 times 1, which is 3. So this is going to be 4. And the square root of 4 is 2. That one works. Let's try our -4. -4 squared. -4 times -4, that'll be 16. And then added to -4 times 3, that's -12. That's going to be a +4. +4 has a square root of +2. Okay, so that worked. But always check your answers. All right, let's try this other one over here, which is very similar, except the radical's not isolated. So we take 14 equals 4 plus 2. There's our radical right there. Okay. So the first thing we're going to do is move everything except the radical to the other side by undoing the operations. So we're going to subtract 4 from both sides. We get 10 is equal to 2, square root of 3, c squared minus 2. To undo this multiply by 2, we're going to divide both sides by 2. And we get 5 equals, now our radical's all there by itself. It's all isolated. So now we can square both sides to get rid of the square root. Square 5, 5 times 5, we get 25. And square the radical here, the square root, and it simply makes the square root go away. And we get 3c squared minus 2. Okay. Now, then, what we have to do, we have a number of choices here actually. Let's add the 2 to both sides to get rid of the 2 here. So we get, that leaves us 3c squared here. Add the 2 over here, we get 27. 27 equals c squared. Let's get rid of the 3. Divide both sides by 3. And you get 9 equals c squared. Okay. Now I've got a square. That means I have probably 2 answers. What number can I square, positive number, to get 9? Well, 3. Right? But I could also square negative 3, because negative 3 times negative 3, that also gives me 9. Now, so those are my 2 possible answers, and I have to go back and check that they both work. So if I take my positive 3 and fill it in for c here, right, I'm going to have 3 squared, which is 9. 9 times 3 is 27. 27 minus 2 is 25. Square root of 25 is 5. 5 times 2 is 10. Plus 4 is 14. That one works. What if I put in a negative 3? Well, negative 3 squared is negative 3 times negative 3, which is 9. So I'm going to get the same thing. 9 times 3 is 27. Minus 2 is 25. Square root of 25 is 5. Times 2 is 10. Plus 4 is 14. So that one works too. Right? All right. That is how you work radical equations. You isolate the radical, right? And then square. Now, if this were a cube root, we would cube both sides of the equation, okay, instead of squaring it. But most of the ones in your book are squares. Okay?